Welcome to MiceTech Talk with the technical information scientists of the Jackson Laboratory. My name is Caitlin, and I'm joined by my teammates Xingtong, Dolores, Sarah, and Janine.
Our team serves the research community by guiding you to important mouse-related resources by phone, email, and educational presentations.
Since we aren't currently traveling to offer any education in person, we created MiceTech Talk to address your questions live. If you're watching live, please use the comment section of the video to tell us where you live, and also, importantly, to share any related questions you may have.
And we really want to encourage dialogue, not just between you guys and us who are talking, but also we love watching scientists help scientists. So, talking in the chat with each other, which we find fantastic.
So today we have our whole MiceTech Talk team on the show because we were fighting out who was going to get to nerd out harder on today's topic. So we decided just to spread the love and have everyone on. So today, let's talk
Our favorite
databases. So it might be kind of an unusual topic because we usually use your frequently asked questions to determine what types of episodes to talk about. But actually, our databases is really what we use to answer all those frequently asked questions. And it wasn't until I got to JAX and realized how much information already lives in databases that I realized so much that I'd been missing out on. So we want to kind of give you a quick overview of this both overwhelming but underappreciated set of databases.
What we really want to do is give a really high-level overview of some of these key databases that we use. And while we're doing this, feel free to ask questions. Ask us to find something. Well, we've got 5 of us on, so we're pretty confident in our ability to find what you're looking for. And then my favorite part is because we only have a short time to go through so much, we want you to vote on which database you want to hear more about. So you get to decide which database that we'll spend an entire episode going deeper dive and really getting into the nitty-gritty of how to use it and how to search and find information. And then once you've voted, we'll have that be our focus for our MiceTech Talk on November 3rd. So let's get started with mouse strain search with Caitlin.
All right, so the mouse strain search and our strain data sheets are probably the database that you're most familiar with if you've been to our jax.org website before. This is where you search for mice in our repository. So today what I want to do is look for leptin receptor mutated strains. And so Janine, if you type in LEPR, which is the abbreviation for that, and you can see that there are several different options to choose from. But the one that I want Janine to click on is the leptin receptor diabetes selection. And what that's going to do is bring up all of the strains that are leptin receptor mutations related to diabetes. And you can see that there are several different strains with different backgrounds and even some strains with multiple mutations. But the strain I want us to look at today is stock number 000642. And what I want to do is show you 2 tips and tricks on the strain data sheet that I think are really underappreciated. So the first one is under the disease phenotype tab that you can see at the top of the page. So click on that. And then you'll see several selections here. And a lot of times we get calls and emails asking, does JAX have phenotype information on this strain? Have we collected and looked at specific phenotype information? So if we do have that information, it'll be listed here under the phenotype tab. And you can see that we have body weight data for this strain. You can also see the mouse Phenome database logo down at the bottom, which will be important later for when you're talking or when Sarah's talking. The last tip I want to show you is under the genetics tab. And you can see under there, there's both mutations that are listed for this strain, but I want to look at the leptin receptor tab. And here is where you can really find some, what I like to call juicy information that you might not be able to find anywhere else. So you can find out what chromosome the mutation is located on. You can also look at the molecular note, which is really where some information lives that can be really important. And finally, I want to point out the blue MGI button that's located next to the allele symbol and the gene symbol. So these two pages are actually different. The gene symbol will take you to the wild type gene, so the regular unmutated leptin receptor. And the allele symbol, where it says LEPRDB, if you click on that MGI button, that will take you to the mouse genome informatics database, which Dolores will talk about here in a second. But I just wanted to ask the rest of my team here, do you guys have any comments about strain data sheets, mouse search?
The one thing that you mentioned, the finding the chromosome, I find that really helpful for some of our transgenic strains if we need to know where the trans gene integrated, or if we don't know, and that's a great place to look for that.
Mm-hmm.
Also, paying attention to the curated references, which will be under the disease and phenotyping section. And you can use this information when you are selecting mouse strains and find out what another researchers has using this model for and what would be their studies looking like.
Mm-hmm.
And lastly, another very common question that we have from people using our mice is, where are the genotyping protocols? And you can find that there as well.
All right, I'll turn it over to Dolores to talk about the mouse genome informatics database.
Great. Before I get started, let me remind our listeners that people can post their questions, so please do in the comment section so we can address them in a little bit. So the MGI database allows you to look at phenotypes described for a particular model, and you can look at the phenotype of a specific allele by genotype, by genetic background, and by affected systems. So since we started with the example of the DBDB mutation that Caitlin referred to in the leptin receptor, let's look at that webpage that Janine pulled up in more detail. If you look at the table tagged as genotype background table, first of all, you can see that the genotype of the disease model for diabetes is actually homozygous. And as you can see, there are several homozygous strains on there in different genetic backgrounds. Actually, we have 11 labeled HM1 to HM11. And if you want to see what phenotypes are observed in the different backgrounds, you go to the table below, the larger table that you see there is called phenotypes, and that will show you in a very convenient summary which systems are affected in each model. Again, it's the same mutation, but in different backgrounds. This is great to understand the model that you're working with, or to select the best model to answer your research questions. For example, HM3 is one of the disease models for diabetes in the BLAC6J genetic background, and HM4 right next to it has the same mutation on the BKS genetic background. You can see right away that on BKS genetic background, HM4, they have additional phenotypes. For example, endocrine phenotype, nephropathy, vision abnormalities that are not seen in BLAC6 background. If you want to look at the details for each phenotype, you simply click on the check mark, and a different tab opens, like you can see on the screen, and that has details of the particular phenotype, the age of onset, how severe it is, and links to papers where they were first described. So this is just one example of how powerful MGI is, and Janine will now show us how you can use MGI to look at CRE resources.
But before we do that, I just want to mention a couple shout outs. We have viewers from Hamburg, Germany, and Missouri State University. So hi, and thanks for joining us.
And I also saw here, someone asked, Elizabeth asked, how often is the phenotypic data updated? Dolores, you want to take that?
That we would have to ask the MGI committee. I know for a fact that I follow Alzheimer's very closely, and I see that for example, there was a release of a bunch of information in July, and MGI has not updated that. Actually, for that, I will have to contact the committee and see how often they update that. But there is a team of researchers specifically working for MGI to update these databases.
Yeah, I was going to try and pull that up. So MGI links to this section on the data sheet where the publications are listed, and I do frequently see database submissions from 2020 and 2019. So it seems relatively frequent, but yeah, it's not going to get everything because it's human beings that have to do this, right?
Exactly. It's manually curated from the literature. There's a team of scientists actually working around the clock to do that.
Yeah, I think that's one of the things that I love about this is that someone actually went in here and used standardized phenotype terms and then linked the publications so you can see it in context. That's my favorite thing about these phenotype sections, and they all basically come from MGI. Okay. All right. So great question. So I'm going to show you another part of MGI that I love. So anybody who is doing Cre recombinase, this is a resource for you. You can get to it from the main MGI page. So if you are trying to do any kind of knockouts or tissue-specific knock-ins, you might be using a Cre lock system. And one of the most important things is to know exactly where your Cre is expressed, and also to find specific Cre recombinases depending on the tissue that you care about. So you can go to the Cre recombinase activity assayed or detected in to search for tissue-specific expression of Cre. And I'll give an example of what someone had asked me a few weeks ago, which was eye surface ectoderm. So she wanted expression in eye surface ectoderm, and it's really nice because it just automatically pops up that tissue. And then also note you can click and nowhere else. Just as a side note, if you click on and nowhere else for this particular one, you won't get any results. So this one is really great. It pulled up 2 different strains that were PAC6 Cre. You can then click on that particular strain that you're interested in, and then similar to the phenotype section that Dolores showed in her example, there's one for recombinase activity detected in. So this one will show you that indeed in a sensory organ such as the eye surface ectoderm, there was positive expression in E9 to E13.9 embryos, which you can then further look at. And you can open up, again, linking the literature, linking the actual data to this database. You can see here's the eye surface ectoderm, where this Cre was crossed to a Laxi reporter, and you can see the nice expression pattern there. The other point I'll show you guys here on the Cre recombinase section here is, I have to delete this now. You can also search by the recombinase driven by a particular promoter. So if you do parvalbumin, for example, and you know you want a parvalbumin Cre, you can find other parvalbumin Cres, many different parvalbumin Cres, including just straight Cres or tamoxifen-inducible Cres. There's actually a FLIP-E, so FLIPase, which is another similar Cre-Lox type of technology, and DRE-ROX and FLIP-Os and so on. What's really helpful about this as well is that you can find where the publicly available strains are located by clicking on this Find Mice IMSR link. And then again, linking out to those references in which this particular Cre strain was used in 502 different publications. Super powerful. Fellow nerds, do you have any other comments about what's so awesome about this?
Elizabeth has another question. She wants to know if we report if there might be ectopic expression of Cre recombinase in any of our strains.
Oh, that's yeah, awesome. Dolores, you want to take that one?
Sure. So there's a big misconception that hopefully with a lot of education, and this is, platform that we can help do that. One thing is what the Cre strains were built for, to express Cre driven by specific promoters. And the other thing is what is reality. And reality a lot of times is that they do not express only where they were designed to express. And actually, the database that Janine showed you, the Cre resource in MGI, would be the best place to go to see, other than when it was supposed to express, where else it is expressing. So we have a lot of strains that were originally designed to express in one tissue, for example, and they express in other tissues as well. So that is, you know, strain by strain, you need to link to MGI. The easiest thing that I find is you go to the strain data sheet. If it's one of our strains, you go to MGI, and from there, look at Cree expression. If somebody has looked into it, it will be posted where Janine explained.
And
yeah, I was going to point out, I was trying to find a CAM kinase 2A Cree that I knew was expressed in like reproductive organs. So this is where you could find that information. So like neuroscientists will realize that this is like a pretty popular neuro Cree strain. But this one actually says that it's also detected in the reproductive system, which can be challenging if you're trying to make a tissue-specific knockout and you're actually making a whole body knockout because of this exogenous or unexpected expression.
And one thing I like to point out is that it's always good to go back to how it was characterized and who did the characterization and whether it was examined, what tissues were examined basically. And that goes back to what Dolores was saying and some of where you can find that information, because sometimes what's ectopic has just, those tissues weren't examined previously, so it may appear ectopic, but it may be what is expressed for that particular Cree. So knowing whether the Cree's actually been assessed in different tissues, or if it was assessed in a very small subset or a specific subset of tissues.
And one more question I want to get to before we move on, because I think this is actually really important. David is asking if we have standard breeding data available for strains that are bred at JAX. And he would also like to know if these are continually updated or if it's just a snapshot.
Janine?
It's not an MGI. We do sometimes, like here at the bottom, let's see, where is it?
Technical
breeding
support.
considerations.
Breeding, yeah.
Sometimes we have breeding information here. There's like multiple places that you can find it. So sometimes it'll say like, this is a really good, like this strain is a good breeder. We have that kind of categorization for like our big production strains. We might not have as much information on our data sheets about like smaller repository strains. So if you can think about it, like, you know, you might be one of like 10 people in the world that's using this strain. Like you can get some information from our data sheet, but sometimes if you just ask us, we can pull them up, especially for those strains that are kind of more unique. And especially if you're kind of like struggling with breeding, you can kind of get some reference to what we've experienced and then see if like this is a strain specific issue or if it's maybe something that's happening environmentally that you might need to address.
Yep. Yeah, the other thing that I wanted to add to that is that if you contact our team, MiceTech@jax.org, we can request what we call internally a breeding performance statistics. We can, if it's a live strain, we can definitely look for the most updated breeding performance, meaning how many pups per liter, how many liters per dam, and things like that. And we can send that to you via email.
Yep. And we try and make that as updated as possible. If it's a cryopreserved strain, so a strain that we don't have currently breeding on the shelf, so it's frozen, sometimes we have some historical data, but it'll be some number of years old depending on when we collected that data. So that's just a caveat for those strains.
Cool. All right. Let's go ahead and move on.
Yeah, finally it's my turn. So I want to show you one of the useful resources that has been linked from MGI and our JAX website, which is the mouse models of human tumor database. So from this website, it contains the PDX tumor models that we have here at JAX. And right now we have more than 450 PDX tumor models from a variety of cancer types, such as lung cancer, breast cancer, colon cancer PDX models. And all of these models are available as a great resources for oncology and immuno-oncology research. So here from this searching page, and you can search for the PDX models by very different filters, which including the ID numbers, if you know, and which you can also search by the primary tumor site, the diagnosis, and maybe your interest genes, whether it has any variants, has any amplifications or deletions in the PDX tumor model. So in today's example, I want to search for the lung cancer as a primary site. And now I'm also looking for the adenocarcinoma models that has a TP53 tumor suppressor variants. So Jenny, if you can click on search. Yep, and here in this page, it actually shows the 69 or 68 matching models. And you can see those models, you can see the primary site, the diagnosis, the P53 mutation types in the model, which also shows the additional data we have for this particular PDX models. Some of them we have histology data, and some of them we have the dosing study as well as histology. And I want to use the J0000966652 as the example for today's talk. Let's take a look at the model details. And here from this page, you'll see we have some very basic patient informations, the tumor site, the primary site, the tumor stage, and those type of information. And other than that, if you scroll down the page, you can also find the histology staining of these tumor models at different passage, whether it's from the patient or from the passage 0, passage 1, at different passage. And for this particular model, we also have the dosing studies, which we measure the tumor growth after the treatment of this standard of care therapy, cisplatin, docetaxel, and the trametinib, or the combination treatments. And this can be used for your references. And lastly, as I mentioned before, you can find out the gene expression data or the variants from the variant summary of this particular page, which contains a list of genes, at least more than 1,000 genes. So this is a very brief summary of the mouse tumor biology database. So please vote for mouse tumor biology database, and we will dive deeper into this if it gets selected. And lastly, let's Sarah. Sarah is going to show you the mouse phenome database.
Thank you, Xingtang. I know we got a question, but we're running a little short on time, so I'm going to quickly go through this, and then we'll see if we can get some more information later. Okay, so mouse phenome database. This is one of my favorites, actually. It's one that I never encountered before until I started in TIS. Mouse phenome database is this collaborative collection of data sets that have been uploaded by investigators from really around the world. These data sets are typically looking at panels of strains in which the mice have been assayed for different phenotypes. It provides a really nice side-by-side comparison for a variety of different strains. Typically, you're going to see a lot of inbred strains, or also, for example, you'll find sometimes recombinant inbred, collaborative cross, diversity outbred. For the most part, you're not going to see some of those specialty mutant strains, so it's really good for understanding more about the underlying biology of some of the different inbred strains, which is how I typically use it. So I'm going to have Janine search for one of our strains, actually. It's stock number 000687. And this is the SMJ strain. So this is the, you can see that, click that link there. It's going to take you to kind of the place where you're going to find a little bit more information. One of the things I love about MPD, just like a lot of our other databases like MGI, is we really link into a lot of our different areas. So for example, you can link directly to the JAK strain datasheet from MPD. You can also link to MGI. So we really try and give you multiple places where you can go from here. You can either look at all studies that have been assayed using this strain, which is 95, but more likely you're probably going to be looking for a specific term. So I'm going to have Janine pull up an example from bone mineral density. And searching. All right. Now, I don't have time to go through all of this, so as much as I'd love to, I'm going to jump into some of the data. But if you vote for MPD, I will go through all the details of what's in this table. So you're going to go to the top link and click on that phenotype measurement. This is going to get you to the direct data that we're going to look at today. And what I like about this is that really it's that side-by-side comparison. I love these. I love the visualization. It really, it's something that I find very helpful. So you can see first off just how different some of these strains are. So this is a great way, honestly, just to see the differences between different strains. And you can also look for the strain that you're interested in. So that SMJ, this is alphabetical, so it's down at the bottom. And this particular data set happens to look at a time course. So it looks at 6 months, 18 months, and 20 months. You can see how that, or 12 months, 20 months. You can see how that bone mineral density changes over time with different strains. So this is one way to search for it. There's a lot of other things you can do with MPD, but I don't have time to go into it all. I just want to say, if you vote for MPD, I'll show you some more things about how to extract data, looking at different panels, some of our specific panels like diversity outbred, some really interesting things you can do about collecting different data and different ways to search. And I know we're running short on time, so I'm going to end it there. Anyone have any comments on MPD?
We do have one question that's come across our screen a couple times that I just want to make sure we address since it's popped up. Do we provide the NCBI numbers for genotyping primers? Somebody want to take that question?
So we do have genotyping assays for our strains on the strain data sheet. You can find that under the technical support tab. The NCBI ascension number, I guess most of the information we get for our strains do come from the donating investigator, so it depends a bit on what they provide. But we do have these validated genotyping assays that we've developed in-house. So if you're looking for a genotyping protocol, I'd probably refer you to our technical support tab.
All right, Ching Tong, wrap it up for us.
All right, so that is all we have time for questions this week, and we have linked a few resources in this video description. Importantly, the first one is a link to the survey of which database you want to hear about in more detail. Please vote for your favorite databases that we'll dive into on November 3rd episode. And then, of course, we link the databases we discussed today below that our mouse search, mouse genome informatics, and mouse phenome databases, as well as mouse tumor biology databases. So our next MiceTech Talk is called the Let's Talk Society of Neurosciences on Tuesday, October 27th. And we look forward to seeing you on LinkedIn and YouTube. And for your information, we will have a webinar this week on Thursday at 1 p.m. Eastern Time, which will be focused on neuromuscular platforms for drug discovery. And so this is Dr. Shintong, Dr. Caitlin, Dr. Dolores, Dr. Sarah, and Dr. Jenny. Saying that staying healthy, stay safe, and stay excited about research.
Bye,
Bye.
guys.
Bye.
Bye.